Hello dear Phasmatic friends! Today, very complicated equations with absolute value. Follow me please. First of all, we see that we have an equation and with three absolute values and also with a fraction. What to do? If you remember our last video, we explained that an absolute value of something will be equal to the same thing in positive if this expression that is inside the absolute value is greater than or equal to 0, and you have to put a negative sign before the expression that is inside the absolute value if this expression is less than 0. Because imagine if you have 4, the absolute value of 4 is the same thing. But if you have a negative 4, you have to add a negative to negative 4 to get the same thing in positive, that is the absolute value. But if that value is less than 0. If you understand that, now we are going to work with the first absolute value, with the second, and with the third absolute value, following the same logic. So, the absolute value of x minus 1 will be equal to the same thing without changing the signs if the expression that is inside the absolute value is greater than or equal to 0. And that will be negative, the same expression that is inside the absolute value, if the expression that is inside the absolute value is less than 0. For the second absolute value, the same thing. That will be equal to the expression that is inside the absolute value if the expression that is inside the absolute value is greater than or equal to 0. And negative, the expression that is inside the absolute value if the expression that is inside the absolute value is less than 0. And after that, the third absolute value will be equal to the expression that is inside the absolute value if the expression that is inside the absolute value is greater than or equal to 0, and negative, the expression that is inside the absolute value if that expression that is inside the absolute value is less than 0. Now we are going to simplify a little bit. We copy everything, but here we can solve this inequality. X will be greater than or equal to 1, because remember that linear inequalities can be solved as an equation, but if you pass to the denominator or to the numerator a negative expression, you change the greater than or equal to sign. Now the same for the second expression. Negative times positive is negative. Negative times negative is positive. If, and we solve this inequality, x less than 1. The same for the next line, x plus 2 if, and here we solve the inequality, x greater than or equal to negative 2. And here, negative times positive, negative, negative times positive, negative. If, and we solve it, x less than negative 2. Finally, we copy the same expression. If we solve this, and here, negative times positive, negative, negative times negative, positive, if, and we solve this inequality, x less than 3. Now, we are going to see what are the numbers here, and we will put those numbers on a number line. So we make our chart. On the first line, the first absolute value. On the second line, the second absolute value. And on the third line, the third absolute value. Now, we see that if we have numbers greater than or equal to 1, here it is 1. So, greater than or equal to is on the right side. We are going to copy this expression, x minus 1. And if numbers are less than 1, so to the left side, we are going to copy this expression. Now, second line, second absolute value. We are going to write this expression if numbers are greater than or equal to negative 2. Negative 2 is here, so numbers that are on the right side of negative 2 will have the expression x plus 2. And numbers that are less than negative 2 will have the expression negative x minus 2. Finally, for the third absolute value, we have numbers that are greater than or equal to 3. The 3 is here, so greater than or equal to is on the right side, x minus 3. Numbers that are less than 3 will be on the left side. Negative x plus 3, negative x plus 3, negative x plus 3. Okay? Now, with the first interval, we will get one equation, another equation for the second interval, another equation for the third interval, and another equation for the fourth interval. What equation? Well, the first expression plus the second expression divided by the third expression equal to 1. The first plus the second divided by the third will be equal to 1. So we write it here. Negative x plus 1 plus negative x minus 2 divided by negative x plus 3 equal to 1. If we have values less than negative 2, second equation, the first expression plus the second divided by the third equal to 1. The first expression plus the second expression with a parenthesis here divided by the third expression equal to 1. If we have values between negative 2 and 1, negative 2 and 1, the x in the middle, and here we will have the signs like that. Third equation, the first expression plus the second expression divided by the third expression equal to 1 if we start in 1 and we finish in 3. And finally, the fourth equation, the first expression plus the second expression divided by the third expression will be equal to 1. If we have numbers greater than or equal to 3. And how to know if I put the greater than or equal to or the less than? Well, always for this method you have greater than or equal to a number and you have less than a number. So here, x less than, not with the equal. X less than a number. But x greater than or equal to a number. Because always when you have in this method greater than, you will have the equal to. Greater than or equal to. Greater than or equal to. But if you have x less than, you are not going to put the equal to. Well, now we are going to solve those equations. First equation. So, to solve this equation, we will pass the denominator multiplying the number 1. And something multiplied by 1 is the same thing. So, we are going to have this equal to this thing on the right side. Negative x plus 1, positive times negative, negative x, positive times negative, negative 2 is equal to negative x plus 3. And now we have a linear simple equation. So everything with x to the left side and everything without x to the right side. So now x will be equal to 4. So now negative x plus negative x, negative 2x plus x, negative x will be equal to 3 plus 2, 5, minus 1 is 4. If we change all signs, we will get the value of x. That will be negative 4. And the very important question is negative 4 between negative infinite and negative 2? Yes. So here we have one answer of our exercise, one solution. Second equation, the same thing. This denominator will pass multiplying the 1. So you will have negative x plus 1 plus x plus 2 equal to negative x plus 3. So everything with x to the left side, everything without x to the right side. And here you have 2x that will be equal to 0. We divide that 0 by 2 and the answer is x is equal to 0. The question is 0 between negative 2 and 1? Yes! So we have another answer of this exercise. Third equation. We will pass this denominator multiplying the 1. So we have x minus 1 plus x plus 2 is equal to negative x plus 3. Everything with x to the left side, everything without x to the right side. And here we will have 3x equal to 1 minus 2 is negative 1 plus 3 plus 2. X will be equal to 2 over 3. Is 2 over 3 between 1 and 3? No, because 2 over 3 is 0.66666. So this cannot be the solution of our equation, because this possibility is for numbers between 1 and 3. Finally, our fourth equation will be this expression that passes multiplying here. You have x minus 1 plus x plus 2 equal to x minus 3. Everything with x to the left side, everything without x to the right side. And here you will have x is equal to negative 4. Is negative 4 between 3 and infinite? No, so we are not going to consider this answer, even if it is the same, because this equation is not satisfying this condition. So that's it. 2 answers for this complex absolute value equation. Thank you very much, dear mathematic friends. See you next video. See you next time.